Now let's move on to integrating the pretension step into our solution, right? So this is just a typical or a usual use case where we actually integrate pretension or any preloading into our model. Okay, so we touched a bit on this earlier about the nonlinear loading condition, especially if you are dealing with continuous nonlinear sum and so on, right? So we touched a little bit on this yesterday. Here we're going to learn how do we use them. Okay, so pretension is what we're going to focus on. Of course, continuous nonlinear sub and then the time-dependent loading is also available. We can use it. But here is where we going to focus multi-step here. First step is where we apply the pretension, okay? And then we use the result of pretension to carry over into the second step to perform any simulation, any kind of simulation, right? So, right, so what is, as we all know, with pretensioning is actually a multi-step process, where the first step we actually perform the pretension, especially even so in the real world, where we actually apply the pretension first. And then the second step only we apply the loading, right? So it's loading is when it's being used in operation or and so on, right? So this with this requirement, we need to separate our steps as well. So the first step is going to be just pretension. There will be no load applied. Second step only we apply that loading, right? So with this, you need to refer with the stat sub pretense here to refer to the subcase where the pretension is being carried out. Okay. Pretensioning can be in Optistruct can be applied either to 1D elements or to 3D elements. So you can model your boat as 1D using a C-beam or a C-bar, and then you can also model it with 3D boats. So if let's say like the example that we had earlier was a 3D boat where we actually meshed the boat with hexa elements, so you can use that as elements for pretensioning, right? So we are going to use something that's built into our HyperWorks, which is the pretensioning manager, to actually help us create that pretension. Right, I'm going to bring you step by step. It's actually very easy to create. Of course, if you look at the cards, you definitely need to create a lot of cards, PT force, PT adjust, depending on whether you're applying force or applying the elongation or the shrinking in displacement to apply that pretensioning. So we can either apply a force, which you need to put in the magnitude, or we can also apply the shrinkage here. So how much the boat shrinks or displaces. Okay, so to apply that pretensioning. So pretensioning can be done in two ways. Again, either in force or in length adjustment, right? So this is the card for pretensioning. Don't need to be too stressed on the cards here. We normally won't see this. Even I don't also see this. I normally deal with the pretensioning here. So it's easier. This is pretty much easier. Okay. Of course, here you need to create the surface ID if you're dealing with 3D pretensioning. With 1D pretensioning, you need to define the element here. So yeah, two different methods, right? We learn here from here. Either we can define it with element ID or we define it with the surface ID. Okay, so that's the pretense that we're gonna apply. Right, so if you're using force to define the pretensioning, we will create this PT force and then define the pretensioning force. Okay, and then if you're dealing with adjustments, length adjustment or the shortening, then we use this PT adjust. Okay, so yeah. So on the cards, you see something like this, where there's a pretense. It's going to be applied on this surface ID. Surface ID here is actually none other than just this, right? And there is this surface ID will be similar to contact surface. Okay, so here will be similar to contact surface. They are the same type of surface, okay. And PT force here we're applying PT force, so we need to make sure that these two SID here is the same. Okay, set ID here is the same. Right? And then this pretensioning is being referred to the pretensioning in the subcase level. Okay, so we need to put in the subcase in the subcase or in the load step early. Later on, we'll see that we need to define that pretension. Right. Yeah. So example of 1D, 1D pretensioning and 3D pretensioning. So with 1D, as you see here, it's just RB2 and then there's a bar, RB2 bar or beam, and then there's a RB2 at the bottom. Of course, with this, you don't see any context, right? Because these PG elements are directly tied to the parts, so you don't see any. You don't need to define any contact. But for 3D bolt, you need to define contact. Okay, that's what we will be using. We have defined contact earlier, so now we're going to apply that similar to this case here. Right. Yeah, so there will be difference whether you have pretension or not. Okay. So no pretensioning, you see the displacement is higher. Okay, because there's no pretension here. This part here can dislodge, can be displaced bigger than compared with pretensioning, right? Yep. So you can also export the values out using pre-tensioning bolt, pret bolt here. So you can export this out into a pret file. Then you can look at this pret file is just a text file, so you can just open it with any text pad and then look at the pretensioning force or pretensioning adjustment values in the file. Okay. Otherwise, you can also print this out to H3D, right? Okay, so we can also look at sectioning. So even to extract any sections out, you can also define this section output. Okay, then this can be output to a section result file as a sec-res file. So this is optional. If you want to output out in the separate file, you can do this. Right. One thing with 1D bolt, we actually create this S point here. So S point is where we actually calculate all the forces, pretensioning forces. So this S point here is like an imaginary node. So it will be created during the run. You don't have to worry about this. But there will be S point created just to let you guys know. Right? And this S point is where we actually extract the results from when we're reading hyperview or hypergraph. Okay. So let's go to the demo now. I'm going to show you how to create that pretensioning for this one. Now, this is the pretensioning force that we're going to apply. So it's about 30 kilonewton applied to the surface there, right? So let's go into that. So in the end, we'll get to see something like this. Okay. Right, so let's pause from the slides and let's go to the model. Right, so okay. Now to define pretensioning, I will first hide these two first, so I don't need the two. I don't need the context as well. Let me hide the context. Okay. And I will also hide half of it because I need a surface that I'm going to apply the pretension. So I will just hide that first because I need to create the surface. I'll like hide this one. And this is where I'm going to apply my pretension. Okay. So go to Analyze, and there's a bolt pretensioning manager here, right? So just click on that. All right. And then you choose either to add 1D bolt or 3D bolt. So it's definitely 3D bolt here. So just add 3D bolt. And you see here, you either choose a existing surface or create new. So I haven't done any creation yet. So I definitely need to choose create new surface, and then select this surface. It automatically creates the cut, surface cut here, right? Create. So this is a surface now, right? Then I return, and you see the surface now is created automatically. Okay, so it's pretty easy to use. So you don't need to go and select you don't need to create the surface first. You can just use this to create, right? Now then you need to go step by step from left to right. So the loading type, I'm going to choose false, right? Load collector, I didn't create any load collector yet for the pretense. So I'm just going to create new. So this create the pretense load collector. You see it being reflected here under load collector. Pretense, okay? Then the ID, leave it blank, because I'm going to define my loading here, 30 kilonewton, right? Orientation, we can just leave it blank because it's going to be normal. So I can just leave it blank like that. Okay. So the rest is okay. All you need to do is just define whether it's false or adjustment. Define the pretense card. You create new, right? Because you didn't create yet. Otherwise, you need to select existing. So just create new and then put in your load here. Okay. And then, yeah, so that's it. Check on this, click apply. And that is the pretensioning created. Right? So yes, it's as easy as that. Okay. So now, yeah, so that's done. You have pretense here. And all you need to do now with the pretense, you need to define it under the load step. Okay. So any question on pretensioning, that's how easy it is to create that pretensioning. All right. Let me create a load step now. So I need to do two load steps. One is the pretensioning, right? This pretensioning load step will contain nothing else but the pretensioning. So I need to use non-linear static because of the context. Okay, so SPC wise, just choose this existing SPC. Let me see here, SPC add. What is inside here? Symmetry and constraint. Okay, fine. Symmetry is just here. Constraint is just here. 1 and 3. Let me just double check on this. Okay, yep, so it's really constrained. Right, so yep, that's fine. Okay, so go back to my load step. Load step, sort my name. Okay, load step, pretense, SPC add. Load, there's no load because I apply my pretensioning here. So it's a pretense, so you need to define this here. This is a pretensioning step, solely pretensioning only. Okay, step is meant to be referred. So this is the first step where I apply the pretensioning. So this is used later on, not now. Okay, you just need to define pretense here. Then NL pump. Let's try small displacement first. I don't expect it to be any large displacement. And of course also NL out. Let's create the NL out. Okay. Put in my number of intervals. Let's just put 10. Of course, I can also turn this on. All right. Now define it back at my subcase. Sorry, not here. NL out. Okay. So NL out and a pump. No contact stabilized, the rest no. Yeah, I guess that's all. So right, the model is okay. Now this is going to be just a pretensioning step, right? We can run this first and make sure the pretensioning works before we set up the second subcase. Okay. Let's have some effect as well. Okay, never mind. I'll let this run first while I set up the subcase for using that pretension. Okay. So now let's just double check contact force is on. Yeah. So I will run this. So pretension is on. Right. Okay. Right. So should run fine. Now I will create a load step or a subcase that uses that pretension model. Okay. So for that, the easiest to set up is just run a model analysis. We can see from that. So model analysis, I need the EIGRL card. If you remember from your linear, course, I'll just extract the first 15 modes. Okay, EIGRL first 15 modes, and then I'll create a load step. Create subcase. I'm going to call this model with pretension, right? So this one, change it to normal modes, SPC. Let's choose free, okay, no SPC, but we choose EIGRL here and stats up here. So you can use Pretens as a preload, okay. So here we use this Pretens here, all right. So you can do this where we apply pretension and in the first step, and then now we use it, okay. Just for comparison, I will create another one, okay, that is without pretension. Oops. Right, no pretension, right? And same thing, no SPC, but now I don't have pretension here as well, just the EIGRL. Okay, so subcase 2 and subcase 3. Right, so let's see pretension run. Yep, it's completed. So you can see we have a summary here. We apply 30,000 Newton, 30 kilonewton, right? So you can see 30 kilonewton applied here for the pretension, right? Yep. So if you look at the animation, do I have hyperview here? Good. Let's just open the model straight away from here. Okay, before that, let me just run the model first. So this one I've created. I'll run this as well. I'll run this as a separate name. And yeah, run that. Okay, so let's look at the initial pretensioning step here. Okay, so pretens from 0 all the way to 1. And you can look at the contact force apply. So initially there's no contact force or 0. And has to be pretens. Okay. Right, so it's maybe cannot see from here. Let me hide one of the components. Okay, so you can see pretensioning that's being carried out. You have contact that is progressively applied. All right. So yeah, pretensioning is working now. Okay, so as I pretension, you can see at the back here where the gasket is, the gasket also get compressed lah. Right. So you can see from the gasket here as well. Okay. Right. So pretension is happening. It has tightened or increased the stiffness here. Displacement wise, you can also see it. Okay. So this is pretensioning step only. Now we see if there's a difference in result for the model analysis when we pretension and if we didn't pretension. Okay, so the easiest you can look from the out file. I think the run is completed. Yeah. So run is completed. We can look from the out file. Let's just go. This is the pretensioning step. Yes, done. Then it uses the result for normal mode analysis, right? So subcase 2 is the one where you apply pretension. This is the frequency that we get. Okay, comparing to without pretension, subcase 3. All right. Yeah, so all these are probably the normal modes or the rigid body mode, so we can ignore them. The real one should only start from, I think, mode 7 here. Yeah, mode 7 should be the real modes, actual flexible mode, comparing to mode 7 here. Right, it's a very small difference because the pretensioning is only on one boat, but you do see a bit of stiffness difference there, right? So once, let's look from the model. Right. Let's load the model. Okay. I'm gonna do subcase 2 here with pretensioning. Eigen mode. So this is mode 1. Yeah, this is so this. Oops. Sorry, let's compare to mode 1. Yeah, this is just the rigid body modes. Okay, so the entire thing is moving. It's just the rigid body modes. The first 6, 4, 5, 6. Okay. So the actual mode starts here, mode 7, right? So mode 7 starts at here. Let me just pause this while I open a second window. Okay. Copy this. And here I will turn to subcase 3. Right. So subcase 3 mode 7. This is the mode. Okay. So similar mode shapes, but then they're happening at different frequency. So it's 1.66 1664 0.3. Here is 0.1. Okay, so it's a bit slight difference because this is only one boat, right? But if you do it for the entire model, then probably you'll see a lot of difference, right? So you can look at mode 8 as well. Here mode 8 as well. Mode 8 happens at 1855. Here it happens at 1858. Okay, so yeah, there will be difference to your model, whether you have pretension or not. Okay. Pause. Right, so that's integrating pretensioning step into your model. Of course, you can go on and create other type of load steps. Let's say if I create now another NL stat where I apply the load. So if I do that, I will use NL stat here. SPC wise, maybe the same or maybe different, up to your use case. Load, you can define load there, NL palm and so on. But here, most important, you need to refer this stat sub here. Okay, if you want to use the result of pretensioning for your next loading, make sure you define pretense here. Okay. Again, remember, you use pretension when you apply pretension, but if you want to use that pretension model, you use under stat sub pretense. Okay, so that's the difference. All right. All right. So yes, that is integrating pretensioning into your model. All right. So we also have yeah. So we learned yesterday preloading. Yeah. Yeah. You just have to be careful of stat sub here. There's a difference between pretense and preload lah, right? So we see earlier was preload. Let me show you guys. Here for the model analysis is model analysis. Stat sub here is preload. Okay, but for NL stat here, the stat sub is pretense. Okay, so remember there is a difference between them. Okay, so if I go back to the difference chart here, if you see a pretense stat sub pretense, stat sub pretense is gonna transfer the stress displacement will be carried over. Okay, so the pretensioning step has I pretense my bolt, there will be stress and displacement, right? So those will be carried over, right? But if I were to use a preload, as in what we saw in the model analysis, it doesn't really carry over the stress, strain, and so on. So initially, there will be no initial stress, there will be no initial strain, right? So be careful with that, pretense and preload, right? But in all cases, we carry over the stiffness. Means that the effect of pretensioning is being carried over, but the result due to pretensioning is not carried over when we use preload. Okay, but modal is the only one you can do. Like you can only do preload. For modal and frequency response, it's just preload. But if it's linear, non-linear, you can choose. Right, you can choose. You can choose to use pretense where we carry over the results here, which is more accurate. All right. Okay, so back to here. So do try this exercise out. It's a continuous from the previous exercise. First, you create a context. Second, you create a pretension, and then you use a pretension for something else, right? For some other load case. Let me see what we have here. I guess here is just teaching you the pretense, and then just run the pretensioning step. So you can do one step further. You can create another subcase and refer to this pretensioning step, right? Like what I did with the model analysis, you can do that as well. So yep, preloading. Yep. So remember, if you use a stat sub preload here, we are just carrying over the stiffness. The stress, strain, displacement will not carry over. Okay. So something to note: context need to be surface to surface here for pretense. Okay. And of course, when you run NVH results, you'll see later on there will be difference lah. Okay, when you have pretensioning done, no matter if it's just 1D pretensioning, you also have effect. Okay. Of course, 1D pretensioning, you might not have contacts from the bolt head to the first part and then the nut to the second part, but you still have contact in between the two parts there. Okay, so yeah, you can consider pretensioning even if you only have 1D bolts. Okay. So this is an example of how do we integrate with modal frequency response? Okay, so we've seen earlier that is with modal analysis, but we can also do the same with modal frequency response, right? So if I just open the model here, or let me just open straight the results. Okay, I'll just show you guys how the model is being set up as well. All right, so this is the model setup. First, there's a pretensioning step, okay, where this is a 1D pretensioning, so the pretensioning is done on all the 1D boats here, which is actually beam elements, right? And with this, there will be contact between the wheel and also the shaft here, this purple color surface, right? So there's the contact and that's the pretension. Okay, if you look at the pretensioning manager, you see the force is being applied, 10 kilonewton at each bolt, right? Then nothing much, contact are pretty much the same. Then we run this for modal frequency response. Okay, so modal frequency response will refer to the stat sub pretense, the stat sub preload. Okay, we cannot have pretense in modal frequency, so the only thing you carry over is just the stiffness. Okay, so that means around the bolts here is going to be stiffer, and we run this for modal frequency response, right? So for results wise, you definitely get to see the difference with and without. Let's try to load the model in. Right, so this is without any pretensioning initial model. Oh, sorry, not this one. Oh, it's 001. Okay, so yep, so this one is without any pretensioning. Okay, and let's look at the result that is at this particular frequency, 500. Okay, so that's this one. Right, so let's open split window. I'll open this one with pretensioning. Okay. This one we look at subcase 2, 500 Hertz, 500 Hertz. Let's open the stress. Okay, here we open the stress as well. Okay, so see there will be difference in the model. Okay, whether you pretense or not. Let's just check 500, 500 model. Okay, so here the displacement is larger because there's no pretensioning. So it's like the bolts are not being bolted, is like very loose here, right? So you see a larger movement compared to this one. Okay. Of course, with this large movement, then you get a higher stress. So here it's going to be like tighten. So that's why you see a smaller stress there. All right. Yeah, because it's not the resonance, so if you move on to resonance, you get to see different thing. Let's try to adjust the scale so that they are having the same scale. Let me check the resonance first. Let's look at the resonance. Slow. Okay. Let's look at the resonance frequency. 580. Okay. So let's look at 580. What's that? Okay. 580. All right. So this is the resonance 580. Let's synchronize this one. Yeah, probably won't see much. Yeah, so the stress here you see is higher because it's being pretension. So yeah, with higher stiffness, of course, you get to see higher stress, right? Here is still free to vibrate. So you see here it's like it's a loose connection here, but here is a really tight connection. Okay. Yeah. So you definitely get different results if you pretension your model or not. Okay. Yep. So that's integrating your pretensioning step into model analysis. So whether it's be it modal or be it a model frequency response, even if you just do a non-linear subcase after this, after the pretensioning, you also will see different results, right? And basically that is all from my side.